We've had a number of requests for Gemma 4.31B. In the last LLM battle, Gemma 4.12B, the smaller dense model, actually held its own. It did quite well. So let's move up. Let's put Gemma 4.31B up against Qwen 3.6 27B and see how they do. Gemma 4's got a slight edge in total parameter count, but Qwen, I think, has got more focused coding knowledge. So this should be an interesting matchup. Let's put the two of them head-to-head in a multi-stage coding competition and settle this once and for all, Qwen versus Gemma. This is Battle of the Dense Models.
No place like localhost. No place like localhost.
Okay, stage one, we're going to get both models to build a simple JavaScript CSS game in a single HTML file. And I know 90% of you just clicked off immediately because that's very boring, right? But bear with me because we're going to get to some interesting challenges in stage 2 and stage 3 if they make it that far. Stage 1 is just a warm-up, and I expect that both models should be able to one-shot this because it's a fairly simple game. The game we're going to build is match 3. If you've ever played a game called Honey Pop, which I have only played for educational purposes, I assure you, you know the general concept of what we're talking about here. You've got a game board with some colorful tokens on them. You can swap 2 tokens to try to form contiguous lines or columns of 3 or more tokens of the same color. And if you do, they're removed from the board and new tokens drop down from the top. Very simple, very straightforward. I expect both models should ace this one. Let's look at our prompt. I described the game. This is on my GitHub if you want to go through it in detail. We're not going to go through it line by line here, but you can check it out on GitHub if you want to read it in detail. We described the game. I described the game board. I described some of the layout elements. You should have a title bar at the top, a sidebar with some current game information. I described the tokens. I described how the game works. I described how it's scored. I described how you move from level to level. I described what I want to see. There's little animations. I don't want the token movement to be instantaneous. It should be animated. And when you match 3 or more tokens, you should get a little sparkly, colorful particle effect. And then there's penalties. If you match red tokens are bad tokens. Red tokens will decrease your score. Every other color will increase your score. Fine. And there's a reset button so you can start over. And there should be detection of an unsolvable board because it's not a guarantee that there's going to be a valid move. So if the game ever detects that there's no valid moves, that's it, game over. Very simple rules. So we're gonna shoot this to both models and see what they can do. And I don't expect we're gonna have any problems in stage 1. But, you know, famous last words, right? So let's start with Gemma. And just really quickly, here's the exact parameters I'm going to use. We're using Gemma 4.31B at Q6. This is the largest version of it that will fit into my VRAM. We're going to use MTP to try to speed it up a little bit. This is a very slow model in my experience. I'm going to use these tuning parameters that I got from Hugging Face, and I'm going to limit it to a context window of 48,000. I know that's a little on the small side, but this is a pretty simple assignment, so I don't think we're going to hit that upper limit. If I go higher than this, it's probably going to spill out of my VRAM. And I know what somebody in the comments is going to say, well, why don't you quantize the KV cache? I don't want to do that. I don't want to use quantization on the KV cache because it might affect the results. I want to keep it as pure as I can. So I'm going to give it a deliberately smaller context window so that it can, without compression, and so that it can do the task hopefully normally. So let's fire up Gemma. Gemma 4 is up. If we look at NV top, we are using 10 gigs out of 12 on card 1 and 20 gigs, almost 21 gigs out of 24 on card 2. So I think we're good. So let's go to open code and tab to our coding agent here, and we'll give it the assignment. Okay, so I'm basically just pointing to the markdown file, which contains the entire prompt. It's about 200 lines of text. Gemma 4 is going to read that and go for it, and we'll see what we get. Now, we've had a couple of requests because I like to fast forward when the model is working. We've had a couple of requests to show a timer on screen while this is working. So I'm just going to make that a bit bigger, and we'll start that. So Gemma 4 is officially on the clock. Let's see what we get. And if anyone's keeping track of speed, we're getting between 22 and 25 tokens per second out of Gemma 4, which is actually not bad for this model. I think it's because I shrunk the context window a bit. In my last test before filming this, I was getting about 21. So this is a little bit faster. It's still going to take a good long while, so, you know, smoke them if you got them. Whoops, I missed the ending. So somewhere around 13 minutes. Okay. Oh, it says 12 minutes 52. So I just missed it. Okay, fine. Let's see. Oh, I guess I can stop the stopwatch. All right. So let's see what Gemma 4 came up with. It looks like this. So I should be able to form a... Oh, yeah, got a little animation there. I can move tokens. Oh, right. You're not supposed to match the red ones. Okay, so... If I pick an invalid move, Oh, it handles the chains correctly, but if I pick an invalid move, it's supposed to flash red to indicate that's an invalid move, and it doesn't. Okay, so minor visual glitch there. If I move this one here, it should match both of these, this column of 3 and this row of 3, and it does. That's a multi-match. Great. And it handles chaining. That's great, and it's keeping track of the score. Okay, so visually, I'd say maybe not amazing. Not sure what I expected, but I mean, it works. New tokens drop in from the top of the board. They're animated. I can match 4 in a row. I get a little bonus for matching 4. That's okay. So, all right. It works. So 13 minutes for Gemma 4 to come up with something that is functional. It's kind of boring, but it's kind of a boring assignment. So I'll accept it. I'll consider this a pass. This is not the end goal. This is just the just the warm up. Visually, we've got the title bar at the top. We've got the sidebar at the side. They're separated by 40 pixels. It looks like you got the layout correctly, almost correctly. There's a slight alignment issue there, and also here, but more or less, it's it's close enough. I'd give it to it. Okay, so I'd say you know what, it's acceptable. All right, let's reset our stopwatch and let's move on to Qwen. Qwen. Okay, parameters for Qwen look like this. It's Q6 also for Qwen, just to keep things nice and even. We're also using MTP for Qwen. I'm using the tuning parameters from Hugging Face for this model. I've turned the context down, even though with Qwen I can fit more context because it's a slightly smaller model. But I'm gonna keep it even. I'm gonna say that both, if I limit Gemma 4 to 48,000 tokens of context, then it's only fair to do the same to Qwen. So let's do that. So let's start up Qwen. And again, I'm not quantizing the KV cache. I'm just going to let it run unquantized. And we get 8.5 gigs of memory usage on card 1, just under 17.5 on card 2. So that is what? 18, that's 26 gigs total. Okay. Let's fire up OpenCode and switch to Ranger 1. And you know what? Same exact prompt. I'm just going to point it to the instructions in this directory and let it go. And start the clock. So what was that, 13 minutes or so for Gemma? I'd expect Qwen to be a little bit faster because this model, what are we getting here? Oh yeah, look at this. So we're getting 38. We're getting 38 tokens per second. What were we getting with Gemma? Was it 20, 25, I think? So we're, about a third faster. So that's great. So it should be about 10 minutes, 9 or 10 minutes, I'm predicting. Okay, I'm not sure what's going on here. I think Qwen might be having a little freak out here. Let me stop that. Did I do something wrong? Let me kill it. Okay, that was very strange. Nothing wrong with the settings that I can see. The only difference from my usual settings is that I turned the context down, but that shouldn't be a problem. It was using only 10%. Let me try it again. Okay, take 2 for Qwen. I've never seen that, so let's start the clock. Okay, 12 minutes, so almost the same amount of time, interestingly, even though Qwen is faster. All right, let me rename that and bring it up. All right, Qwen's looks like this. So, okay, I think, I like how the tokens drop down from above the board instead of just teleporting in. That's kind of a nice touch. I think the animation is a little bit nicer for Qwen. It's handling the text pop-ups okay. Let me just restart that. Let me get a better start here. Okay, it handles multi-matches. It handles chained matches. Okay, it looks like it's scoring it correctly. If I'm not mistaken, I think Qwen's looks a little better. Let me bring them up side by side. This is Qwen. Here's Gemma. Yeah, look at this sidebar. Qwen styled it, centered it, and put little horizontal rules. Gemma's looks a little more plain. Even the board looks, I think the borders are slightly thicker on the tokens. I think it's just a little bit sharper visually. And I like the animation. I like how the tokens drop in from above the board. Little stuff, little details like that. I've got to dock points because Qwen took 2 attempts. The first attempt, it just went off the rails. I've never seen it do that before. Okay, but it got there on attempt 2. This is a simple assignment, so they both more or less one-shotted it. I'll give a slight edge to Gemma for getting there in 1 step, although it did take an extra minute. And I'll give a slight edge to Qwen in terms of visual presentation because it just looks a little bit nicer. Just a little bit nicer. Even the pastel blue background that I asked for, I think it's just slightly nicer on Qwen than Gemma. Maybe I'm nitpicking. They both work. They both got there. They both solved the assignment. Great. If we were to stop there, this would be an extremely boring episode. What's the point? Of course, a model can one-shot a simple HTML game. That's too easy, right? Stage 2. What we're going to do is we're going to give each model the code output from stage 1, and we're going to ask it to port this game with all of the rules to a completely different tech stack. We're going to go from HTML, CSS, JavaScript to, let's say, Python and Pygame. Animation in particular is handled completely differently between these 2 tech stacks. In JavaScript, you can rely on CSS transitions to do your animation. In Pygame, you've got to do them more manually. So it basically requires a rewrite of the animation code. This is an interesting challenge because it depends on how well structured your code was. If your code is really clean and well structured, it shouldn't be that big of a deal to pull out the animation and rewrite it. If there's hard-coded stuff everywhere in the code, it's going to be a bigger lift. So we're going to see if they can successfully port it. But 2 plot twists. Number 1, I am deliberately not going to give the models access. We're going to start in a new session, and I'm not going to give them access to the original prompt that created this game. I'm only going to give them access to the JavaScript code that they output. This is to simulate more or less a real-world scenario. Let's say you get hired as a developer at some company, and your first task is to go into some big mess of existing code and fix some bugs in it and extend it or port it over to a different language. And there's no documentation for this code, and you go looking around like, oh, can you tell me who wrote the code? I can go ask him a few questions. No, he doesn't work here anymore. He hasn't been here for 2 years. So you're on your own. You got to figure it out. This is kind of a more realistic scenario where you've got to reverse engineer the rules of the game and the scoring of the game just by looking at the code. There's no prompt, no documentation to help them with this. Plot twist number 2, and I kind of like this one, they're not going to modify their own code. Each one is going to port the one generated by the other. And my reasoning for this is that Qwen and Gemma, both models, might have their own coding style. Even if you guide them with a system prompt, which I did, my coding agent has specific guidelines for things like, generating clean code and separation of concerns and all of that. But each model might have its own way of writing code, and if you ask it to refactor code that was written by it itself, it might kind of recognize or at least sense that, okay, this code is structured the way I would have structured it, so I understand it, right? But again, we're trying to simulate a more real-world scenario where you get asked to go in, jump into somebody else's code, and you look at it and you say, I wouldn't have written it like this. What was this guy thinking? And sometimes this guy is you from 6 months ago, but never mind that. This is an interesting test, I think, in that we're asking the model to modify code that it didn't generate to port it over to another platform. And just to throw a little bit of an extra twist in it, I'm going to ask them to add sound effects. I've got some sound effects ready to go, and I've got a little mapping of which sound effects are mapped to which game events. There was no audio in the original game, so this is a new requirement that they're going to have to bolt onto the side. So let's see how each model does. And then if both models can succeed at this, we're going to move on to a stage 3 where we're going to add a new game mechanic. But let's see how we do in stage 2. I don't know how this is going to go. Okay, so the prompt we're going to use looks like this. And this is all they're going to have access to. I'm going to hide the original prompt so they don't get to see the detailed description of how the game is supposed to work. It looks like this. In this directory, you will find a match3.html containing a match3 game implemented in JavaScript. Your task is to port it to Python using the Pygame CE library and no other dependencies. Try to keep it as visually close to the original as possible. Same color, same game board dimensions, all of that stuff. I'm going to tack this on. If you find bugs, deficiencies, or inefficient code patterns, you are allowed and encouraged to improve and enhance them. The game rules have to be the same though, and I'm going to make up the story about how the original documentation has been lost, so you will have to reverse engineer the rules of the game by examining the code. So little things like red tokens are bad and other color tokens are good. Things like chained matches or multi-matches, all of that kind of stuff, the text messages that have to flash up on the screen and the duration of them and the animations and all of that stuff, you got to figure it out. So I know this is confusing because we're crossing the streams here, but we're going to get Gemma to port over Qwen's code, and we're going to get Qwen to port over Gemma's code. This is both going to be done in a brand new session, so they've got no context as to what came before it. And let's see what we get. So since Qwen is already running, I'm going to let Qwen go first, and I'm just going to start a new session. Okay, so find your instructions in the refactor markdown file and output your stuff to this directory. I'm going to reset the clock. This is Qwen porting Gemma's code to Python. And let's see what Qwen can make of that. Clock is started. Go, Qwen, go, and good luck. Okay, Qwen just stopped randomly at the 17-minute mark, and it's only using 38% of its context. This is 2 for 2. Qwen has never behaved this way before. I think it's because I cut its context window size down, and my camera battery is about to die, so I'm going to have to switch to camera 2, and I'm going to have to reset Qwen. I think I'm going to increase the context size, but let me swap cameras. Okay, minor technical difficulties there. I've never seen Qwen behave that way, but to be fair, I've never run it with a context window that small for a task like this. So I've doubled it. We're going to run round 2 is going to be 96,000 tokens of context for each model. That's going to slow things down a little bit, especially for Gemma, but it is what it is. Let's do a mulligan. Same directory, same prompt, same input. I'm going to start Qwen. I've reloaded it with 96,000 tokens of context. We're using about 30 gigs of VRAM, and let's see if Qwen can do this. Okay, 8 minutes in, Qwen is reporting success. So let me just pause for a second here. I think it ran out of context. OpenCode is saying that we're only using 32% of our context window, 30,000. But I don't know how accurate that is. I wonder if OpenCode is underestimating how much context is actually being used. It feels like on both previous rounds, Qwen ran out of context and fell over and died. Expanding the context to double what it was allowed it to finish in 8 minutes. So it's just a guess on my part as to what happened. I normally run Qwen with 128K of context, so I can't say I've seen that before. Anyway, let's see what we got. It generated a Python file. Okay. We lost the token movement animation, but for the swap, I'll still do the drop-in. From the top, it's still scoring correctly. That should decrease my score, and it does. That should increase my score, and it does. Okay. That should give me a multi, and it does. Okay. Okay. That visually is pretty much in line with what Gemma came up with. Let me bring up Gemma's. Let's do a direct compare here. This is round 1 Gemma, match 3. So that was the source game that it had to work with, and this is what it came up with in Python. That is pretty much visually identical. I'm a little disappointed that we lost the... Does it do it here? Yes, it does. It does a nice little animation of the token swap. You see the token actually move. Here, it just sort of teleports. Let me find one. We lost the token swap animation. Everything else seems to work. Okay, that's a faithful port of Gemma's version of the code. Rather than fiddle with it, I mean, I'm sure we could tweak it, but I don't want to lose time. Let's move forward. Let's now let Gemma take a look at Qwen's code and do the same thing and see if we get a quality port of the code that Qwen came up with. Okay, I think we're ready. All right, so Gemma's loaded. We're using 11 out of 12 gigs and 23.4. So I'm sure the context window has spilled over into system memory. This is going to be much slower, but it is what it is. Let's give it the same exact instructions. Refactor is there, and Qwen's output from round 1 is there, and the sound effects are there, and that's all it has to work with. So let's let it go. Oh, let me bring the stopwatch back and reset. Let's let it go. Start the clock. Okay, stop the clock. 15 minutes, 40 seconds. Gemma is not going to win any points for speed on this particular round, but let's see. Did it output? Yes, it did. It outputted a match3.py. Okay, let's see what we got. start it off screen. Let me bring it over here. Okay. Visually, is the window resizable? No, it isn't. So visually, it didn't add a margin around the... I'm nitpicking, I guess, but let's see if we... Oh, look at that. So it handles matches, it handles chains. It kept the token animation. I think... So this is difficult to score. I think Gemma did a better job than Qwen did, but Gemma was starting with Qwen's code. And Qwen had to work with Gemma's code. If I want to do apples to apples here, I should really get Gemma to port Gemma's code and Qwen to port Qwen's code, so we'd have 4 outputs, you know? This is actually not bad, other than the fact that there's no margin around it. I don't like that visually, but in terms of functionality, this is pretty good. I wonder if that's because Gemma just had a better starting point than Qwen did. Does this distract? They should subtract points. It does. They should give me a bonus, and it does. The text color is wrong, but that's okay. So minor things that I noticed visually that Gemma got wrong, but it kept the animation, and it kept the tokens are appearing from above the token. So yeah, I think Gemma had a head start here, because it got to work with code that was generated by Qwen, and I think Qwen had slightly better presentation code in the source. So that's interesting. But Gemma was able to... This should count as a double match if I do this. Yeah, so Gemma was able to port the game quite well. I'd even say a little bit better than Qwen did with what Gemma left it. So the text color is wrong, and there's no margin. Other than that, I can't find any flaw. It even kept the centered and stylized... sidebar that Qwen came up with. So if you give Gemma a good starting position, it can do fine work. A few little minor things that I might nitpick, I'm sure we could clean them up if we did multiple rounds of this. So let's side by side it. Let me bring up round 1. Qwen looks like this, and round 2 Gemma, based on Qwen's code, looks like this. So visually, other than the missing margin, this is pretty much bang on. I'd say that's really good. Let me find a match here. I think the timing of the animation is just slightly off. I'm nitpicking now, but the tokens seem to swap a little more slowly in the Python version than they do. Oh, maybe I'm wrong. I don't know. Could be my imagination. So, little minor things. I'm not going to nitpick it. We're not going to do multiple rounds of this. Let's move on to stage 3. Since both models have done well so far, let's move on to stage 3. Stage 3 is to take the output of stage 2, again, without being able to see the original prompt that led to the creation of the HTML game or the Python port. I'm just going to give them the Python source that was the output of stage 2, and I'm going to ask each of them to implement a new game mechanic. Let's take a look at this. So it looks like this. New feature. So in this directory, you will find a match3.py containing an implementation of the match3 board game. And I'm just going to give them a little bit of an overview of how the game works, so they don't have to. So they've got a little bit of a head start on reverse engineering it. And I'm going to introduce a new feature called magical tokens. These are tokens that have a horizontal or vertical stripe on them. And if you match one, it clears the entire row or the entire column. This is a new feature in existing code. And again, we're going to swap the streams. We're going to get Qwen to modify the code, the Python code that Gemma output, and vice versa. Again, this is to try to keep the models on their toes, because they're going to be working with code that they themselves did not generate. So this again is kind of trying to simulate a real world test where you've inherited code written by somebody else and you've got to extend it. It's not a matter of just straight porting it to some other tech stack. Now you've got to add a new feature. So again, we're going to be testing how modular is the code, how easy is it to add a brand new feature, a brand new game mechanic to this. I know this is kind of a trivial example, but this is like a scaled down version of a real world problem, and I want to see how each model approaches it. So let's reset. I've got Gemma already loaded, so I'm going to... Okay, so close that and close that. Let's reset the stopwatch, and let's get out of here. And let's go to round 3 for Gemma. Looks like this. We've got the Python that was output by Qwen, and we've got the new feature prompt that we just saw, and the sound effects directory is there. And that's it. It doesn't have access to the original prompts. It doesn't have access to the original HTML code. It just has that. Let's start it up. Switch to Ranger 1 and say, So find your instructions in new feature.markdown in this directory, read them and execute, and good luck. Let's let Gemma go to town on that. I'm going to start the clock. I wouldn't say this is a significant new feature, but it is a new mechanic, so let's see what it does with it. Okay, 15 minutes. I was watching HTOP on Saturn as it was working. All 24 cores were pegged, so yeah, the context is too large to fit in VRAM, so is what it is. Gemma 4 is not going to win any points for speed on this round, but that's okay. Let's see what we got. Match 3. Let's bring it up, and the spawn chance of a magical token. Let me just reset. There's one. There's one right there. So if I match this striped token, every token in this row should be cleared, and I should get a big score bonus. Let's see what happens. All right. All right, let me try it again, if I can find another one. Yeah, there's a vertical one, so every token in this column should get matched when I do this. Okay, yeah, beautiful, beautiful. Looks good, visually looks good. The animation still works, everything is still good. And we have that random spawn chance of a magical token, which gradually increases as you make more matches. I love it, excellent. Gemma 4, well done. I'm impressed so far. One more, and that is Qwen will now attempt to do the same thing, but with Gemma's round 2 output as its input. Let's reset and give that a shot. Okay, so what we've got is Gemma 4's output from round 2 is in this directory, and the new feature prompt that we already looked at, and the sound effects, and that's it. So we're going to fire up open code. I've loaded Qwen. I'm going to switch to Ranger 1, and I'm going to bring up the same exact prompt, and let me bring in the stopwatch and reset it. And we're off. Go, Qwen, go. Okay, 12 minutes for Qwen. Surprisingly, the two models are pretty close in speed. I was expecting Qwen to be twice as fast, but interestingly, they're not that far apart. Okay, let's see what we got. All right, I see a magical token. Let me restart until I get one that I can match. There we go. All right, here's one that I can match. So every token in this column should be cleared when I do this. Oh, no, they're not. Okay, let's try a horizontal one. Every token in this row should be cleared when I do this. And they're not. Wow, it missed it. So Qwen either missed the requirement or there's a bug in the implementation. Let me take this back to Qwen. Okay, just gonna ask Qwen to take another look. Let's you know what? Let's add this to Qwen's time. Gemma did not need a rework. Now, to be fair, Gemma was working with Qwen's code and vice versa, so it could just be that Qwen was dealing with Gemma's sloppy code, and it's hard to tell exactly what went wrong here. This is a difficult one to judge. Let's see what happens here. My camera's dying. I got to switch back to camera 1. Okay, that took a crazy long time, but Qwen claims, let me stop the clock here, 21 minutes total time. That was what, 12 minutes for the original implementation and then 8 minutes for the bug fix. Let's see if it actually fixed it. So I've got one right here. It should clear this entire row when yeah, it does. Okay, cool. Let me restart. Okay, here's one. So if I match this token, it should clear this entire column. And it does. Okay. All right. Both were able to do it. Qwen actually took longer and more attempts than Gemma, but they both got there. And again, that could either be because Qwen didn't do the assignment as well, or because it was working with Gemma's code, and maybe Gemma's code was sloppier. You know what we should do? We should do a code review of both implementations. Let me set that up. Okay, I've got the round 1 results, the original HTML files from both contenders, and the original prompt that was used to generate them. I'm gonna, somebody in the comments suggested, I think we got a couple of suggestions actually, that we shouldn't be using one of the contenders as the code review LLM because, you know, conflict of interest. So I'm gonna use my personal GitHub Copilot account. Okay, so I'm going to say something like this. In this directory, you're going to find 2 HTML implementations of a match 3 game. Each was written from the same prompt. You can find the prompt in this directory. Take a look at both implementations and grade them in terms of cleanliness and structure, and also adherence to the original prompt. Let's see what code, Claude Sonnet 4.6 is going to take a look at this. This is going to eat some tokens from my allotment for this month, but that's okay. Okay. Let's take a look at this. So, summary. I'll put this on my GitHub when we're done here. Wow, Gemma gets a C+ in all categories. Qwen B- to B+. Qwen is the stronger implementation. Gemma has numerous bugs. Both have shared failures. Okay, interesting. I'll post the entire. Let me just write this out. Okay, let me save that. Interesting. Let's move on to a review of the round 2 results. Okay, I'm going to get Copilot to review the results of round 2 and see what we get. Let's reset the clock. I don't know why I'm timing Copilot. It doesn't matter. Okay, 3 minutes for that review. Let's see what we got. Qwen is significantly cleaner. Proper state machine, namestates. I'm not going to go through it line by line. I'll post this all on my GitHub. Gemma's weaknesses. Summary. Qwen has better, cleaner code by a wide margin, but a critical regression bug, level advancement, is completely broken. Gemma's code works as a playable game despite its messiness, but the rules diverge from Qwen on chain scoring. Neither implementation is bug-free, and they are not consistent with each other on scoring rules. Interesting. Please write this out to disk so I can post it on my GitHub. Interesting. Okay. Let me reset, and we'll do one last review on round 3 to see which LLM did a better job at implementing that new feature. Okay. So we're in the stage 3 directory now. So take a look at these 2 different implementations of match 3. I've also included the prompt for the new feature. So please tell me which one did a better job of implementing this feature. Better means cleaner code patterns, fewer bugs, and then I'm just going to tell it to write it to disk so I don't have to ask for that separately. Okay, let's go. Okay, review complete. What do we got? The winner is Gemma. Gemma's implementation is architecturally superior, but Gemma was basing its work for that new feature on Qwen's output from stage 2. So this is confusing. This is tough to score this. To do this scientifically, I should have had Qwen port Qwen's code and then extend Qwen's code, and the same for Gemma. I'd have to go back to 1 and do it all again, and I've already collected like 3 hours of footage, so I don't want to do it. So I'll tell you what, I will leave this as an exercise for the viewer. I will post the results of each round on my GitHub in the AI Playground. You can check them out, and if you've got access to these models, you can do that chain. You can have Qwen port Qwen's own HTML code and Gemma port Gemma's own HTML code, and then extend the new feature and compare the results, because this is a kind of a confusing mess. What I was trying to test was their ability to pick up code written by an unfamiliar LLM and still work with it. And both models succeeded. Both models were able to hit more or less the target. It looks like there's some bugs that Copilot has found. And it's saying that Gemma had the better implementation at the end of round 3, but that was based on Qwen's implementation from round 2. So the architectural things that it's complementing here are actually Qwen's architectural accomplishments. So this is a confusing and complicated thing to score. So tell you what, post in the comments down below, which one do you think won and why? And was it a mistake to cross the streams like that? Because is that just confusing the matter unnecessarily? This was not a highly scientific thing, but it was kind of a fun little experiment. I deliberately picked something simple because I thought it would be an easy task, but we wound up with a spaghetti mess in both cases. Okay, there you go. That was kind of a fun little contest. I'm not sure who won, but we wound up with 2 more or less functional implementations of the same game. And yeah, I'm gonna look at the code, I think, myself and pick a winner. I'll post my results in a follow-up comment maybe, or on Discord or something. That reminds me, we do have a community Discord. The invite link is in the channel description. I'll post it in the video description as well. So come on by if you want to have a chat. And yeah. Have fun, and we will see you next time. We've had a number of requests for Qwen. No, we haven't. What am I saying? 3, 2, 1. We've had a number of... Don't hit the microphone.